Hi, and welcome to your tutorial for doing your calculations to complete your Thermos challenge for 6 weeks project. In the next couple of minutes, I'm going to take you through in detail how to do some sample calculations like the ones on your lab and hopefully earn the full 50 points that are set aside for this portion of your project. On your rubric, the part 2 for calculations, if we can put in some sample numbers, I'm going to go ahead and say that our water temperature to start off with, if we were doing this experiment, I would go ahead and take your temperature at the beginning before we set the timer and at the end after 10 minutes. Let's say if this particular student started off with an initial temperature of 100 degrees Celsius. And at the end of 10 minutes that their final temperature was 80 degrees Celsius. So what we would fill in here, and I'll do that with you as we finish out your calculations, is that their temperature change would be found by subtracting the final temperature, 80, minus the initial temperature, 100, which would equal a delta T of negative 20 degrees Celsius. As far as point values are concerned, we'll go ahead then and take that number and subtract 3 from it, since you guys are allowed to lose 3 degrees, and we find out that this kid gets a total amount of points for section 1 as 17 points earned. 17 points out of 30. So moving on to part 2, what we can do with those numbers would be to start off with calculating the quantity of heat lost from your thermos. If we can go back to the thermodynamics unit, we find that your equation for heat gained and heat loss is Q equals MC delta, let's find the delta symbol, stop it, delta T. So in this case, our heat is going to be equal to the mass of the water. If you go back on your instructions, we all know that the volume of water put into the thermos was 200 milliliters. And what the unique thing is about water, is that because the density of water is 1 gram per milliliter, whatever our volume is, the mass for water and water alone is also equal to that same number. So if we put in 200 milliliters of water, that mass of your water will also be 200 grams. So we can plug that in for M. If you can think back, the C value for water would be on your notes, which I guess I'm not going to give it to you right now. You can look at your notes or you can Google it, but you'll plug in the C, specific heat capacity of water. Let's leave that blank and let you find it to fill in. And then we're going to do our delta T, which we already found out from part 1 was this particular example. For this student, I said that they had a delta T of negative 20 degrees Celsius. Come on, negative. All right, so I'll go ahead and type in right here, negative 20. Of course, for your particular experiment, you'll type in whatever your real delta T was, and we'll multiply. For your answer, you should come up with Q equal to, and stop and think if your answer should be negative or should it be positive. Keeping in mind that the positive and negative would indicate heat gained or heat loss respectively. So you'll get a number for Q, and then we'll also have the unit of measurement for Q, which would be joules. Okay. If all that's done correctly, that first question is worth 20 points. Moving on to question 2. Now it asks you to calculate the work done by the system on the air inside the container. So if we can assume that, if we can recall rather, that the equation for work of a gas in a container is equal to W equals P times delta V. Let's bring our delta symbol V. So to figure out the work for this particular student, we would follow this process. We would look at the pressure, which up here in the problem, you're guided that the pressure we'll assume for our project is equivalent to atmospheric pressure at room temperature. So I've provided you the number of atmospheres that you can fill in for P. Also, for the change in volume, the problem goes on to tell you, hey, this is how much the volume changed. It expanded, went up by a total of 1 milliliter, which is equivalent to 0.001 liters. So for this equation, you'll kind of have to do some research to figure out, is it the milliliters that we need to put in for volume, or is it the liters? So in that case, you can also refer back to your notes or do some research online to see what unit volume should be input as. Once you find the appropriate volume unit, you can plug it in for delta V here and simply multiply those two together to get your answer for work. Last but not least, we need to put a unit for work. Oops. So again, this tutorial is just to guide you on the steps to take and not give you the exact answers, but whatever numerical value you get from multiplying the pressure and the delta V, you're going to have that measured in joules as well, because work and heat happen to share the same equation. Last but not least, problem number 3 says calculate the change in internal energy. So you'll recall from your notes once again that change in internal energy is delta U, delta meaning change, U meaning internal energy. That is equal to Q plus any W. So here's where your first two answers are going to totally depend on you getting this number 3 correct. We do have points set aside for the process, but in order to get the full points, you would need to have the process as well as the correct answer. So now we go on and we say, for delta U, whatever number you got in part 1, you're going to plug it in as Q right here. So I'll put a little note that says, answer from equation, or I should say calculation number 1, calculation 1, and you're going to add to that the W answer from calculation number 2. Answer for calculation number 2. Keeping in mind your positive and negative signs that you get for Q and also that you get for W need to be put in with these answers so that when we add them together, you can make sure that you get the correct answer for delta U. So for Q, that's either going to be a positive or negative number, and for W, that's either going to be a positive or negative. We'll add those together and get your delta U as your calculator tells you. I hope this has been helpful, and good luck on receiving your maximum points for the calculations in part 2.